I'm at the Ellwood Bluffs in Santa Barbara, just above sections of the Monterey Shale. And what we're gonna do is just go down there and look in those cobbles for some petrified whalebone. What I'm going to do is set a timer to see how long it takes for me to actually find some whalebone. Okay, here's some petrified whalebone, right? Pretty cool. This piece is nice and orange, and you can really see the bone fibers in there. And this took me about 10 minutes to find, actually almost on the dot. And I just started right over there. So I might even be able to walk back real quick to show you. But yeah, I also think it makes sense to walk back to show you what's happening and why you can actually find these things pretty quickly. I mean, a lot of this isn't whalebone, but it's easy enough to find a whalebone here than you might expect, which I'll get to shortly. So I guess, you know, you're seeing kind of where I sort of slowly walked along, and then I actually started. Where is it? Oh, just right there. So found it there, started there. Nice, beautiful whalebone. So right behind me, we have a little outcrop of the Monterey Shale, which defines a lot of the sea cliffs here, right? And this unit was deposited in the Miocene, which is about 5 million to 20 million years ago, when whales were roaming the oceans and swimming. And these deposits are shale deposits. This is really fine. Find a nice example. Rock made out of a lot of clay minerals and whatnot. It's a very common sedimentary rock that forms at the base of the ocean, right? And so what happens is when whales would die, their bodies would sink to the ocean floor. And just so you're aware, whales evolved maybe about 50 million years ago. So in the Miocene, they were thriving, right? And in the rock unit behind me, right, the Monterey Shale, you don't really find a whole ton of whalebone when you're just walking along. You can, but what actually happens is fluids kind of percolate through, and the rocks undergo what's known as diagenesis. And for very porous rocks like bones, where you can see there's a bunch of old pores there, the fluid likes to percolate quickly through. So what you wind up having is you get this bone and it gets replaced by a lot of silica, and it becomes very, very resistant to weathering. So as the shale behind me breaks down more easily, you have a lot of parts of shale that have been silicified, and also the whale bones become silicified. So as you're walking along, you wind up having more resistant whalebone than the bedrock that it's in. And so yeah, I'm gonna walk you guys through this at home with a few samples of mine to sort of illustrate the process, but hope this helped being out in the field. Okay, I am back at home, and my plan is to talk to you a little more about how whalebones, or petrified whalebones like this, form and are pretty easy to find along the coast in beds of cobbles, at least in Southern California. So when the whale dies and sinks to the sea floor, after the body decomposes, a lot of the time what remains are the bones. And as your sediment sort of starts to accumulate, you bury those bones. So once the sediment is lithified, more or less, you can fracture it. And what'll happen in those fractures is the fluids that I discussed will percolate through. And sometimes you'll get these wild veins of quartz, and this one has a lot of nice crystals in it. You can see here in the video. So if you're not really familiar with bone, it tends to be very porous, right? And in this, you can see a lot of the pores, In this sample, you can see a lot of those pores. And what happens when you have these silica-rich fluids migrating through the rock is that they'll find this region where there's bone, and they'll be like, okay, I can migrate in that direction. And it'll react with hydroxylapatite, or whatever the bones are made of, replace it and form, instead of apatite, calcium phosphate, you get this silica-rich cobble. Compared to the shale that hasn't experienced the silicification, these whalebone cobbles, right, they're much more resistant when they become silicified. So as the sea cliffs erode away, you have these waves bombarding against the sea cliffs, making them erode back every year so much, you know. And the whalebones, which have been silicified, will drop out and they'll tumble around and become a lot more round, right? Whereas a lot of the shale, some of it will become round, like some of it's been silicified, but a lot of the shale is very soft and will break down quite quickly. I also mentioned that whales evolved about 50 million years ago, give or take. And so you're not going to find whale bones in every shale bed or every sea cliff. These are trilobite fossils, right? And any shale bed with trilobite fossils is going to have formed millions of years before whales were ever on Earth. So if you have sea cliffs that are solely formed with very ancient rock, you're not going to find any whale bones because whales hadn't evolved yet. Now, depending on the timing, you may be able to find the bones of like an ichthyosaur or, you know, some sort of dinosaur that was a marine dinosaur. But yeah, you know, look for the stuff that's younger than 50 million years if you're going to look for a spot for hunting whale bones.
So another thing you should be aware of here is that there are sections where you're not supposed to collect. So I actually got this sample over here, but right where I'm at and to the east, you're not supposed to collect bones, fossil bones, shells, stuff like that. And other marine protected areas you should try to look up beforehand and be aware of, right? I know this area and I know you're fine to collect anywhere here, but if I weren't very familiar with the area, I would look it up beforehand.